Okay. Thank you very much, Priyakshi, for the opportunity to talk about the lithium-ion cell supply chain, assessing India's capabilities. During the presentation today, I plan to cover 3 chapters mainly. First chapter about electric vehicle market in India, then a little bit about demand of LIBs from automotive and ESS applications. Then moving on, I'll talk about current battery supply chain in India, which includes battery and pack manufacturing status, cell manufacturing and PLI scheme, cell component manufacturing, and eventually I'll conclude with the raw material scenarios. Several points have already been covered by Rahul and Utkarsh. So I'll keep skipping some of the contents which are common in the presentations. Moving on to the electric vehicle market globally, if you look at the numbers, so the global electric car market has been increasing more than 50% in last 7 years. Obviously dominated by China, followed by Europe and then US. China has the largest EV fleet with 7.8 million cars, followed by Europe with 2.3 million, and then United States with 2 million cars. Let's have a look on the situation in India. So if you compare the numbers from 2018 to 2022, there has been significant jump in last 2 years. So if you compare the number from 2020 to 2022, it has been growing with the CAGR of 188%, more than that. And if you just compare last 2 years number, it has grown more than 200%. So that is a fantastic growth which India has achieved. And with this level of growth, the debate whether EVs are going to happen in a big way in India or not, I think has no place now. So it is obvious that India is moving towards electrification. So let's also talk about a little bit about different vehicle segments. On the two-wheeler segment, initially the two-wheeler market was completely driven by startup companies, but with time, non-traditional players are also entering into the game. Similar is the case for the three-wheelers. Now you can see majority of the traditional and the non-traditional players in the three-vehicle segment. Initially, the market was dominated by mostly e-rickshaw segment, but now you have a lot of vehicle sales from the L5 segment also. Moving on the passenger vehicle status in India, I think passenger vehicle or the passenger cars took some time to come up with the products other than Tata and Mahindra. But now, if you see all kind of vehicle manufacturers, you will find in coming into the electric car segment. Those who are not present, within a year, you will see the product introductions mainly because of the CAFE norm introduction. And also with the CAFE norms, heavy penalties are being imposed with the cap of 25,000 per car and 50,000 per car if you miss out the targets. And so one thing has been very common across the segments, that initially the product quality was not so good, but in all vehicle segment now you will see better quality products coming on year by year. So if you compare the batteries, motors, inverters, initially the low specifications were there, but now the specs, battery sizes are improving, and with time they will keep improving. That also in the end will solve the challenges of probably for recyclers also, because ultimately we are going to come up on some particular kind of battery chemistry, which Rahul has also talked about in the beginning. It is important to understand what kind of vehicle segments are going to grow in future, and also what are the reasons behind that. So if you look at the electric two-wheelers, currently electric two-wheelers are mostly growing because of the applications such as food delivery, e-commerce goods delivery, hyperlocal grocery delivery, and personal commercial commute. In future, you will see other introduction of other applications such as racing bikes, etc. Electric three-wheeler has different use cases, and they will continue growing with those kind of similar applications. In passenger cars, In four-wheelers, you will see currently there are passenger taxi for intra-cities mostly, and the personal commute. But in future, the mostly it is going to shift towards passenger taxi, intercity, intra-city also, and then racing cars, off-road cars, caravans, etc. are going to be introduced. In e-buses and truck segment, it's currently mostly goods delivery with the e-commerce companies and the public transportation. But in future, several other applications might also emerge, such as public transportation, intercity and state, and school and college buses. These are some of the applications. Obviously, there will be several other applications also in future. Now moving on to the demand of lithium-ion batteries from automotive and ESS applications. Globally, the demand has been growing very fast, and the demand is mostly for the passenger EVs. If you look at the India situation and talk about Indian battery demand estimated numbers, so in Indian estimated numbers, you will see this is an aggressive scenario, probably a little bit of challenging to achieve these numbers, but yes, this is the kind of aggressive case which we can consider, and mostly dominated by stationary storage, grid scale, followed by electrification, which includes mix of vehicle. And in this case, if we take such case, then the battery demand is expected to rise to around 230 gigawatt hour by 2030. And currently, we do not have even any gigafactory. So there is a huge potential demand and huge possibility of the lithium-ion battery manufacturing in India. Several battery chemistry options, which other speakers have already talked. But what I would like to communicate here is that the current applications which are there, current battery technologies like LFP, NCA, LMO, several are there. But in future, you will also see phasing out of some of them and introduction of different battery chemistries. Obviously, different battery chemistries for different applications. But if you look at only for passenger cars, so in our opinion, it is mostly going to be NMC and LFP. And in several vehicle segments like buses and cars, it is mostly going to be the LFP chemistry. Why so? Let's have a look on the current battery supply chain in India. So it is a natural progression that we start from pack manufacturing and then we eventually end up to the cell manufacturing components. But in this progression, currently we are mostly into the pack manufacturing status. You can see the different kind of companies, categorizing different kind of companies. The purpose is to understand what efforts at what level and in what direction Indian organizations are doing in the lithium-ion battery manufacturing. So we have companies like Ola, Reliance, and Rajesh Export, which have been awarded under PLI scheme. Then we have traditional battery manufacturers, which have a very good understanding how automotive industry works. And also probably they have much better experience working with the automotive OEMs. So their experience is also going to work a lot. So their presence is inevitable in lithium-ion battery manufacturing. Then we have non-traditional players also, such as Mahindra, L&T, India Power, Thermax, Tata Chemicals. There are others also, and also there are startup companies. So there are a mix of companies mostly exploring the pack manufacturing currently, and in future they plan to have cell manufacturing. Let's have a look on the challenges of a, let's say, passenger car OEM. What are the challenges they are facing with the current level of supply of the batteries? So if you look at the current supply of batteries, mostly challenges are in terms of very high cost of batteries, inflexibility with the battery design, safety and cost of the transportation, also delaying in providing services, government policy and localization push. That has to be addressed. So automotive OEMs in India are not only depending on the battery manufacturers, but they themselves also plan to be somehow to be present in this entire battery value chain. For example, some of the OEMs with the vehicle manufacturing, they also want to be present probably in the cell manufacturing with a JV with a company. Why this is extremely important for automotive OEMs in India is that first time, I think in last several years, the battery prices have gone up and mainly because of the increasing raw material prices. So in order to have a control on the demand, they need to be present around all parts of the value chain. Then, so that is how the cell manufacturing from all angles becomes very important in India. And there has been a very important initiative. We are all aware about that, PLI for ACC applications with a huge amount of budget. And it is a fast-tracked program also. And eventually we have 3 players with the Hyundai, with the removal of Hyundai Global Motors, because they were probably not able to meet some of the criteria. So now we have Rajesh Exports, we have Ola and Reliance. Other than PLI for ACC, government is also planning for the PLI for niche chemistries, wherein you will see introduction of different other battery chemistries, maybe not in that level of a scale, but for niche applications, there can be other battery chemistries also. Some of the collaborations like C4V has a collaboration with OSM, and OSM is bringing the C4V technology in India with the semi-solid state batteries, which they have. There are other organizations also pitching as part of the PLI for niche applications. Now moving on, if you look at the plans, the plans which are disclosed by these companies, for example, Ola Electric has been working on the capacity building of 1 gigawatt-hour in 2023, then moving to 20 gigawatt-hour in 26 and 27, and in very long future, they also think about 50 gigawatt-hour battery plant. And such companies are better placed because they have a captive demand, so they can meet their two-wheeler captive demand, and in future, if they come up with their passenger cars, they can meet passenger car battery demand also from their in-house factory. And obviously they are open for other OEMs for across the vehicle segment. If you look at the plan, I'm talking about the companies which are part of the PLI scheme. So Reliance has also won the bid, and they have collaborated with 2 companies, Lithium and Faradium. Lithium with LFP chemistry. So you will see a lot of LFP chemistry batteries going into their automotive applications. And then Faradium is sodium-ion battery for future applications. Let's also talk about their LFP battery component. So there is a difference between NMC and LFP in terms of their cell cathode constitution. And if you compare both the chemistries, LFP chemistry is quite favorable for India because of the low constituents of the cell cathode and also high possibility of manufacturing. On fundamentally or theoretically, 69 to 90% of the value can be captured for LFP in India, but for NMC it goes only around 43% theoretically. So LFP basically here also is kind of a winner in terms of the value addition, and value addition is important because 60% of the value add criteria under the PLI scheme. Moving on, cell component manufacturing. I'll take some time and explain about the need of localizing the downstream supply chain. So if you break down the vehicle into different cell into different parts, so you have assembly, you have materials, you have cell manufacturing. So around materials constitute around 40% in general about a vehicle, about a battery, and mostly currently India has very limited presence around any kind of material. But if India targets to achieve 60% of the value add, then we need to localize anode, cathode, electrolyte, and separator at least. For anode, there are several companies like Epsilon, Mitsubishi Chemical, Himadri, HEG, and it seems that India is a better placed in terms of anode manufacturing. There are some initiatives in cathode also, like Alox and Epsilon. And then in electrolyte, we have companies GFL, Neogen, and in separators, we have Daramic. Let me have a look on the anode manufacturing status in India. So how these companies are basically trying to capture the anode manufacturing market. So first target is approval from global battery manufacturers, because currently there is not much demand in Indian battery companies. So they look at potential anode manufacturers, look at to get the material approved from global players such as Panasonic and LG first. Becoming a supplier of such players definitely gives a very good advantage and acceptability to all kind of battery manufacturers. As global players enter in different geographies, they can also enter together with them and try to capture the other markets. Second point is exports to lead demand. Anode manufacturers in India are making plans for manufacturing based on not Indian scenario, but the global scenario. Domestic demand for local cell manufacturing companies is expected to take at least 3 to 4 years in India. So that is how supplying and having a very good experience globally is going to add a lot of value. Then Indian anode manufacturers are favorable because preference of non-Chinese suppliers. So this is the thought process of Indian anode manufacturers for Indian market. So I'll now talk about some company initiatives. For example, in anode, Epsilon is one company which has been very aggressive. And if you look at, they produce mesocoke, which is a precursor to anode material on a commercial scale of 2,500 TPA capacity. Pilot facility to manufacture synthetic and natural graphite. If you look at their future plans, by 2030, they plan to have capacities around 100,000 million ton of the synthetic anode and 50,000 million ton of natural graphite. Similar plans you can see for Himadri Chemicals also. And in future, they plan to produce around 20,000 MT by 2022 and to produce 100,000 million ton of anode material by 2028, obviously in a phased manner. Now I will move to the cathode manufacturing. Any, be it anode, cathode, separator, electrolyte, generally they look at two things mainly. One, security in terms of demand, and also proximity to the natural resources. Somehow, unfortunately, India doesn't places very well on those two criteria. So India's specific challenges are lack of clarity on demand, lack of government push and schemes, lack of technical expertise, availability of raw materials. These are the key challenges what a downstream vendor for any kind of material is facing, especially for the cathode manufacturing. But yes, at the same time, there are companies like Alox who can be one of the potential or the future players who have announced the manufacturing of cathode materials. And in future, if you look at the current situation, they enhance the imported material into LFP cathode through a patented process, and then current cathode manufacturing capacity of 50 kilogram per day. But if you look at the future, they plan to go into commercial production by 2023, end of the 2023, and increasing the production capacity also 10 to 15 tons per day. Moving on, separator manufacturing. I have one example of Dynamic, and in future, they plan to start a greenfield project for manufacturing lithium-ion battery separator, and when the demand increases. They're a Asahi Kasai group company and have aggressive plans also for separator manufacturing in India. Then Neogen also has a plan, and they basically plan to scale plant for electrolyte and lithium salt production for captive consumption to be set up later, not now. And and GFL also have very aggressive plans. I think we are all aware about the initiative, so I'll skip this. And moving on, I will cover raw material scenario in India. I think majority of us are aware about it because Rahul and Utkarsh both covered this topic. So I'll briefly touch upon it. Cobalt, nickel, aluminum, lithium are majority of the components which goes into the lithium-ion battery. And if you compare the NMC, because we concluded on LFP and NMC chemistry. So on LFP and NMC chemistry, you have lithium, nickel, cobalt, and manganese. and India somehow only present into the nickel raw material, not in lithium and cobalt and manganese. So that's a very big challenge for us. The reuse of batteries and very strong ecosystem of recyclers is going to play a significant role, a very vital role in the electrification journey of the country. Because if you compare, the demand role of different materials like lithium, cobalt, and nickel, EV demand is going to surpass, I think, other applications. So it's really very important to think about the circularity and start not only taking, making and using, but also reusing and recycling and closing the loop. As Utkarsh was mentioning, that India has very limited capability in terms of metal production. It's all dominated by China. Wherever they are not into the metal production, they have gone ahead and captured entire value chain of the metal processing. But that's also one of a big opportunity for India, wherein we can try and build capability. So because company to company collaborations are not going to help such capability building. So there is a huge requirement of having G2G collaborations, and NOLCO, MECL, and organizations have basically come up with a very good plan. And it's like something similar model of ONGC Videsh. So India has set up a joint venture company, Khanij Videsh India, and that has been created by Ministry of Mines. So that is a very good plan. And other plans also are from NMDC. So once these G2G collaborations picks up, India is going to solve majorly such challenges. So these are my thoughts, Priyakshi. Thank you very much. And I would like to thank my team who contributed in making this presentation. Thank you very much.